Good afternoon, everyone. Today, I would like to talk about the 2022 Nobel Prize in Physics. I chose this topic because it deals with one of the most fundamental questions in science: how nature behaves at the quantum level. The prize was awarded for experiments with entangled photons, establishing the violation of Bell inequalities, and pioneering quantum information science. Quantum mechanics describes the behavior of particles at extremely small scales, such as atoms and photons. One of its most surprising features is quantum entanglement. Entanglement is a phenomenon in which two particles become linked in such a way that the state of one particle is directly related to the state of another, even if they are far apart. This idea challenged classical physics, which assumes that objects have independent properties. To test this concept, scientists conducted experiments based on Bell's theorem. Bell's theorem provides a way to determine whether the predictions of quantum mechanics are correct or whether hidden variables could explain the results. Experiments with entangled photons showed that Bell inequalities are violated. This means that the results cannot be explained by classical physics or hidden variables. Instead, they confirm the strange predictions of quantum mechanics. These experiments demonstrated that reality at the quantum level is fundamentally different from our everyday experience. The research also laid the foundation for quantum information science. This field includes technologies such as quantum computing, quantum cryptography, and quantum communication. For example, quantum entanglement can be used to create secure communication systems that are theoretically impossible to hack. Quantum computers may solve certain problems much faster than classical computers. I find this discovery very fascinating because it challenges our intuitive understanding of reality. It shows that nature behaves in ways that are not always predictable using classical logic. In the future, quantum technologies may transform computing, communication, and data security. Even though quantum phenomena are difficult to understand, they are becoming increasingly important in modern science and technology. This award reminds us that exploring fundamental questions can lead to revolutionary applications. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2022 Nobel Prize in Chemistry. I chose this topic because it introduces a simple and powerful approach to building molecules, often described as click chemistry. The prize was awarded for the development of click chemistry and bioorthogonal chemistry. In traditional chemistry, synthesizing complex molecules often requires many steps and can be time-consuming and inefficient. Scientists have long searched for methods that allow molecules to be assembled quickly and reliably. Click chemistry provides such a method. It refers to a set of reactions that are simple, fast, and highly efficient. These reactions work under mild conditions and produce minimal unwanted byproducts. A key feature of click chemistry is that it allows small molecular units to click together like building blocks. One of the most important examples is the reaction between an azide and an alkyne, which forms a stable connection. This reaction is highly selective and works well in many different environments. Building on this concept, scientists developed bioorthogonal chemistry. Bioorthogonal reactions are chemical reactions that can occur inside living organisms without interfering with natural biological processes. This is extremely useful for studying biological systems. For example, researchers can label specific molecules inside cells and track their behavior in real time. This allows scientists to observe processes such as protein interactions and cellular activity. Bioorthogonal chemistry has also contributed to medical research, including drug development and diagnostic techniques. It enables precise targeting of molecules within the body. I find this discovery very important because it simplifies complex chemical processes. It transforms the way chemists design and construct molecules. Instead of complicated procedures, chemists can now use reliable and predictable reactions. This approach also promotes greener chemistry by reducing waste and improving efficiency. In the future, click chemistry and bioorthogonal methods may lead to new advances in medicine, materials science, and biotechnology. Even though these reactions are simple in concept, their impact is profound. This award reminds us that simplicity can lead to powerful innovations in science. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2022 Nobel Prize in Physiology or Medicine. I chose this topic because it reveals how modern humans are connected to ancient human species through DNA. The prize was awarded for discoveries concerning the genomes of extinct hominins and human evolution. For many years, scientists studied human evolution mainly through fossils. However, fossils alone could not provide detailed genetic information. The development of techniques to extract and analyze ancient DNA made it possible to study the genetic material of extinct humans. One of the most important achievements was sequencing the genome of the Neanderthals. Neanderthals were an ancient human species that lived in Europe and parts of Asia. By analyzing their DNA, scientists discovered that modern humans and Neanderthals interbred. This means that many people today still carry small amounts of Neanderthal DNA in their genomes. This finding changed our understanding of human evolution. It showed that human history is not a simple linear progression, but a complex process involving interaction between different human groups. In addition to Neanderthals, scientists also discovered another extinct group called Denisovans. Their DNA was identified from a small bone fragment, demonstrating the power of genetic analysis. The study of ancient DNA has also revealed how certain genetic traits were inherited. For example, some genes from Neanderthals influence the immune system of modern humans. This suggests that interbreeding may have helped humans adapt to new environments. I find this discovery very fascinating because it connects us directly to our ancient relatives. It shows that our genetic identity is shaped by interactions over thousands of years. This research has also contributed to the development of new methods in genetics and evolutionary biology. In the future, further studies of ancient DNA may reveal even more details about human origins and migration. Even though ancient humans are extinct, their genetic legacy remains within us. This award reminds us that understanding our past is essential for understanding who we are today. Thank you.